Jom. Let's Sembang AIoT. I know Amir is watching. Yeah. Okay, very good afternoon, everyone.
Good afternoon, everyone. My name is Daniel.
Cecily here. So, how are you today? The KL and the whole Malaysia weather is always full of cloud. Yeah. So every day also very cloudy. Sometimes raining.
Especially during when you want to go back.
Yeah, traffic jam everywhere. So thank you for watching us today. This is a very special sharing also for today. We want to show you more. I think last week we talked about something related to OCR, AI, OCR. Kelly is going to bring you more OCR today. But before we start, I think you can also, I think I asked some question, in the past live session. How many times you have been asked by your IT people if you are engineering department? So how many times you are asked by IT people, hey, how can I get your data, through a web API or OPC UA, or how can I present that into the cloud? Yeah. That is a common thing that dealing with IoT, as far as the boss is concerned. I think those bosses want optimization. In your manufacturing, you want optimization. You want what? You want cutting costs. Yeah. Cutting people, less manpower. These are the things that the boss is very concerned. So how this IoT data we have been sharing, this will be our 21st. Yeah. If you are already grown up 21st, you are actually Merdeka already. 21st is very special, very special day today. So bosses are very concerned about all this the effectiveness, efficiency, how AIoT is able to bring you. These are the things that, or the topic that we keep on sharing until now. So thank you for watching again. Please SSL, if you are regular in our channel, SSL stand for share, like,
subscribe.
Share, subscribe, like. Yeah. But don't do TLS. TLS is tak nak like and tak nak subscribe.
For example, to read some reading from the meter.
Read some meter reading. Yeah.
So previously we did some AI on this. We using we read on the analog meter. So today we will use the OCR, apply it on the digital meter.
Yeah. Just before that, when I think about 3 months or 4 months ago, when we first started talking about this AI, the very first thing to me is one of this analog meter, not analog meter, the water meter. Yeah, someone is doing on the water meter, on some AI also. Is it AI? Reading the number. Yeah. It's a pure OCR. Okay. But we don't know whether AI or not AI reading vision that tell you the numbers of the meters. These are the things that we spark up. Some of the things that we pushing us to do. Using AI to read all these things. Later on, are we going to have something like that? Yeah. Maybe you can continue.
Yeah. So now we need to share.
We need to share the screen.
Share the screen.
Okay. Okay, this part.
Okay, so for this one, now you are looking at the water meter.
Yeah.
Yeah, just outside our office.
That is a water meter that I'm talking about, you know. Yeah. So that was a water meter with the AI. So similar model that we used last week, right?
Yes.
So this part we are going to show you, you know, how is it accurate, you know. So this is a 1, 2. Okay, let me read from the side It's a 1, 2, 3, 5, 3, 2, 2. One at the right hand side is 1, 2, 3, 5, 3, 2, 2. But I think the picture at the back, the last character is not so obvious, so the AI don't know what to do about it.
Because the last character blocked by something. I think there's a pointer, something like that, something blocking it.
Yeah, this part actually is very important. That's why when we every time we talk about data set, you know, this data set is actually very important, and also your viewing angle and so on. That will actually affect your results that you are getting. Okay, so that is the this guy is running at how many? Yeah, we have one colleague. You know, he's working on that thing. You know, to show. Oh, that's another one.
Yeah, now it's another one. So this one is the.
This one can be an indicator a process indicator. Yeah, process indicator. As you can see, the process indicator here, it is not so stable. Because this one is building on top of another screen. So the thing is not very stable, but almost, you know, is getting the right reading, 79. Of course, when it comes to AI, you can still further train this one. This one, we just put it on, you know, free flow. Yeah, free flow. So maybe we can move to next.
Yeah, we'll move to the next one. This one is a.
Is it a power meter?
Yeah, it's a power
this is one of the energy meter. Yeah.
So the result, 3769. Yeah, and then the bottom is 5800.
This is very stable. Yeah, this is very stable. So talking about energy meter, you know, we of course we have a model doing this analog gauge meter. This is another set. This is another set. So it's totally different. That one is very analog. This one is purely digital. But within the digital, there is another digital. Yeah, that means AI is another digital. Previously, when we did, if you follow us in our exhibition, also we showed that analog gauge with the meter, with the AI. That's analog to digital using the AI. You know, this is a digital to the digital, digital to the digital using AI. Yeah, maybe we can move on to the other one, or you want to speak something about that? You know.
Yeah, because some of the digital meter, although it's already digital, showing you the digital value, but there is no way for them to share you the data. So you only can look at it, and then you need someone go there to record down the value. So especially those digital meter that doesn't have some Wi-Fi or other communication protocol to share the data out, then you still need a human go there, an operator go there to record down the value.
Yeah, to all those bosses who is watching, let's say you are watching us, you know, until the 21st only you start watching us. Yeah, please do, you know, we have something, maybe some ideas that you can use, you know, to manage better in terms of your human resources and so on. You know, sometimes all these things can be, you know, AI is able to replace certain part of the human being. Of course, it won't be able to do everything. Yeah. So that is one of the case. You know, let's say you have somebody want to do the recording every day. That data is very important. It's actually affecting your process or your quality, you know, wastage, all those things. Yeah. So with this one, AI is able to do. And then why we want to do this one? Very important. Why we want to do it non-intrusive? This is non-intrusive.
This is non-intrusive.
Why we want to do it non-intrusive?
So by using this method, it won't disturb your existing system.
Yeah.
You don't need to put any wire on your system.
Especially for those people who are running their production non-stop 7/24. please, they will tell you, don't touch my system because we are chasing for the delivery. We are coping up with all this delivery, so we can't stop. So, but the data is still very important. Yeah. So this part will play a very important role in terms of a non-intrusive reading, no matter whether you are analog gauge or
the
digital meter. Okay, we can move on. Yeah?
So by using this method, you can get the real-time data already. Before this, you need someone go there, enter the data. So if you have 100 or 1,000 of meter, so the data you receive sometimes is already not considered real-time already. So with this method, you can get the data every second.
Yeah.
So when you have a lot of data, what you can do next? You can do data analytics. You can start to, maybe you want to do some anomaly detection, you want to do forecasting, you want to do predictive maintenance. Now you're able to do this thing when you have a lot of data.
Right. Right. So coming to that also, I think, let me see, about 4 years ago, we at Yomtech, we have one of the kit, we have one of the kit that do the same thing like what in this case, the same concept, non-intrusive data extraction, non-intrusive data. I don't know why we every time talk about non-intrusive. So this is a third cases, third case already, still non-intrusive. That time is a non-intrusive data extraction. Non-intrusive data extraction during that time is, a lot of old machine, they have this CRT green color one, or black and white, or some colors lah. So it will give you all this reading on this monitor. But same thing, right now, if you want to gather all this data, you are not able to gather because this machine is simply too old. Too old to tap the data. How can you do that? Actually, during that time, the non-intrusive is we actually intercept the VGA connector going out. VGA is driving the CRT. You can put in between one box, like T-joint like that, one in and out, and then in between, the video signal is shared to another system. That system is actually doing some also OCR, but maybe it's not using the pure AI thing to do some algorithm, because OCR is very, 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 very old technology, very mature technology. So it can do. So for this case, we do not need to put extra box there. We can just put a simple camera, set up one simple box, embedded box to perform this. Yeah.
You no need to modify the VGA cable anymore.
Yeah, today actually somehow
now it's already purely non-intrusive.
The one is really non-intrusive. You don't touch anything.
The previous one you still need to touch the VGA cable.
Yeah, sometimes doing this sharing is good for us. You know why? Some of these ideas just came in. I didn't plan to talk about that. Actually, since we talk about non-intrusive, I recall some of the things that it can be done the same way here, and then it can be quite efficient. I still remember some of these people or some of the friends asking about this solution at that time. Yeah, this can be one of the solution to them. Yeah, we of course talking about that. Yomtech work very closely with system integrator, project system, project house partner. So that part, if you have some of these things, do talk to us. We would like to share more and how we can work together to materialize this, because our mission is to make AIoT great. Actually, how great, how great is depending on how much problem it can solve for you. Yeah. So that's very important. Okay.
Yeah, so I will continue. So by automate this process, so now you no longer need a person go there at a regular interval to take the reading already. So now you can allocate that person to do other job. And then with this, it can increase your productivity already. So if you think that you don't need that person anymore, then cut your cost already. You no longer need that person to do this job for you anymore. And at the same time, some of the meter is installed at some very hard to reach location. So for example, at a very high place, the rooftop, or some hazard location.
Hazardous location.
So where if you ask someone go there, you need to give them a very high pay in order to find someone go there to get the reading.
Right.
So and then since now you no longer need to physically visit the place anymore. So actually it's one more benefit that not many people notice.
Yeah.
Because now you no need to travel to there.
Yeah.
At the same time, it reduces the carbon footprint. You don't need to drive your car to there.
So whatever we do all here, it's very green.
Yes.
So it's
safe the environment.
It's actually complying to the framework of ESG. Something related to ESG. Yeah. Okay.
So the last one is now you get the data already. The data it can integrate with other software. For example, the energy management software or the utility software that can help you to do the billing, that kind of thing. Because when we have the meter, sometimes we need to do the billing, that kind of thing. So it's more easier for you to integrate the data with other third-party software.
Yeah, integration is also actually integration. When we talk about system integration, this is also one of the pillar in the Industrial 4.0. Since I think we started that with the Industrial 4.0 also. Yeah. So system integration part, allow you to integrate. That is very important. Sometimes you want to do integration, but there's no point that you can integrate. So once you digitize it, then that possibility is there.
When you manually record down the data, it's very hard to integrate. So when everything is automated, then the integration process will become more meaningful.
Correct. Yes. Okay, that is a pressure transmitter. Yeah, a pressure sensor. Pressure. This 003, not 007, 003. 003 is very consistent. This part the OCR is done in a very consistent manner. Okay.
Is there any more image, Amir?
Any more? Of course, there is.
This one is a process controller.
Process controller. Yeah.
So the reading, is correct.
Why we chose those meter is also we started this one in the past 5 sessions. We talk about temperature, we talk about pressure, we talk about process controller, transmitter, we talk about agriculture sensors, and so on. So these are the possibility that we pick up, where AI, not only IoT can do, AI also can do in this non-intrusive manner. Okay, this part is the process controller 3.15 is very.
Now we have the temperature sensor.
This is a temperature controller actually,
Temperature controller.
Temperature controller. Or maybe just an indicator lah. This is just an indicator. So this one also very consistent. From the left hand side, some of our audience maybe is marked, pink color. Actually, that is to tell the AI in action, right?
Yes.
The bounding box there, red color. It's not purposely we try to hide it. Is the AI is.
Indicate the AI already found this number or character over there.
So how many frames per second right now? About 25.
On the top. Usually it's around 40 something.
40 something, that's 25. Yeah, okay.
So, is this the last one?
Okay, no more. So I think that is very interesting. Having this digital meter using the digital to read the digital, in a non-intrusive way. That is a very special thing that happened in Malaysia, happened in Exomtech Malaysia, and also happened together with me from Sicily and Kenya. Okay, so that is the AI part. So for those of you who are still watching us today, we wish you a very nice weekend also. But then, very important, we need your feedback. Yeah, we need your feedback. If you have any comment at all, please do write to us. Or if you want to hear some special thing about AI thing, we are always you are always welcome. We try to see what we can do for you. Yeah. So is there any more, Kenan? No. Okay. There is a request last week asking about what is AIS. How does the AIS function? Maybe Kenan, you want to share something?
Okay. So AIS is using the supervised deep learning. So supervised deep learning means you need to collect the data set, and then you need to label the data set. So this one, the AIS is for the computer vision. So your data set is all images. And then when you label, we have tools in the AIS, so where you can draw the bounding box and then label what is inside the bounding box. So this is the labeling process. After that, the third process is you will go through the training. Train the AI model with your label data set. And then the training process is you don't need to do anything. You just configure on the user interface, select which model you want to do, how long you want to train, and then which data set you want to use, and that's it. And then just click the start button, and then just wait for. That one depends on your hardware capability and also your data set size. So usually within 1 hour, and then if your data set is very large, maybe take a few days. So there's no correct answer for this thing, how long it's going to take for the training. And then after the training process, and the last one is the inference. So which means you're going to do the deployment. So that one, actually you just select the model that you've already trained, and then connect your camera or input your images to do the testing. That's it, only 4 steps. Collect data set, labeling, training, and inference.
Okay. So talking about that AIS basically stand for this AI suite. It's an AI development kit that is suitable for some people who like to build their own AI model.
For the object detection and the classification.
That can be performed by your own team, or you yourself also can involve in building this AI, where you do not need any programming background at all. You're using these tools. You do not need any programming background. It's a kind of end-to-end from machine learning to deep machine learning, deep AI learning, up to the end to this inference result. This is very good for people who want to build the proof of concept. Even we have made it to be a practical model that can run even in your process, in some of the process. So of course, just talking like that maybe is not, if you're still not very clear. I still remember the name. This Mr. Faiz. He asked about this one. I think you can also refer to our website. That is published in our website. So talking about all this AI, of course, IoT. Today, I'm going to share you more about especially good for those engineering people who are want to do some measurement, who would like to use IoT as one of the platforms to visualize your data onto the cloud or onto the other platform, for example, web API. So I think we have done the very first one on this OPC UA, getting this one to on OPC UA, you can host the data on the OPC UA server, letting other people to gather data from you. The second thing is we have shown live also, I think the last one, on the web API. So that also with web API, that's why I asked you, are you IT people? IT people want to use a web API to gather data. That's very, very standard. And then, of course, cloud. We have done that so many times. So I don't think we are going to show you anything cloud. But just simply by sharing some of the thing that you currently, still those things is still needed in this IoT application. So this is one of them. Yeah, you can see the slide here. This is one of the something related to what? Something related to this digital city or smart city. People want to measure. I think from a manufacturing, smart manufacturing, to the smart agriculture sensors, and then this will be the last one on a digital city or smart city, where people want to gather data from their sensors. For example, a PM 2.0, like for example, haze. Right now, haze is very annoying. This PM 2.5 can be captured by these weather station sensors, and also something like HC, HO. Sometimes these are chemical terms like formaldehyde. Formaldehyde, I think, is toxic, right? Formaldehyde is very toxic. And total volatile organic compound. These are TVOC, carbon dioxide, carbon monoxide, hydrogen sulfide, ammonia, all these things, all these gases. If let's say you are able to place this kind of mini weather sensor or station, you are able to tap this data, and then you are able to do as what we have just shared. I think you can do OPC UA, you can do web API server, and then you can also do what? See on the cloud. That is our common way of sharing. Okay, so today I just want to show you how we are still having a setup here, a temperature, RTD. We put the RTD to show OPC UA and a web API. But then today I just want to show you how this, what is the significance of using RTD to measure temperature. Yeah. So this is part of the, why I want to pick this part out is because it somehow attracted me so much, when you look at this bridge circuit, in the electronics, you have this bridge circuit. This bridge circuit is very special. It appears in most of the instrumentation. I think last time I showed you before on the pressure sensor, how you measure. They are using the same circuitry to do measurement. For this case, it's the temperature, where resistance change, temperature will be able to be measured, using the A to D converter and so on. But just want to show you why RTD, there are 2 wires, 3 wires, and 4 wires. These are very common things that people, like what we are having, how many wires? I think we are having 3 wires here. 3 wire.
Yeah, 3 wires.
Yeah, having a 3 wire. Can I show you a probe? Can you show me? Yeah, sorry. Yeah, this probe is one of these RTV sensor that I think can measure most of the, not so much on the environment temperature but more on the liquid, on some water, or in some process you use this one to measure. I think in the building management they use this sensor. So why is this a 2 wire? 2 wires is the lowest end, as you can see in the diagram. The RT, when the temperature change, that circuit, you can see the VO. What we do is on the A to D converter, you actually measuring the VO, the voltage output. When the temperature RT change, it will create an unbalance in this circuit, and then give you a potential difference. The voltage is measured from there. So, but problem is, you can see the lead wire resistance. Every wire, like for this case, we have this wire this part. This is a sensors, but this is a wire. So this wire, the longer it is, or not so good of the wire, it will give you so-called a lead resistance. This lead resistance is R, is indicated as a R lead. Now these two resistance, when you increase, along the you put a longer distance, it will give you error in your reading. That's why two wires is only good, if you are not so particular about the temperature accuracy. So that is the two wires. You have this problem. Two wires, three wires, or four wires, also you have the same problem. But how can these three wires able to help you in getting more accurate data? Okay, that is the thing that you can see in my next slide. This is the three wires. Three wires is like for this case, three wires. So you can see here, it's part of one of the mathematical equation here. You can see from the bottom there, the third line, RT plus R lead equal to R3 plus, R3, RT and R3 are different. So this R lead in the circuitry here, the equation is cancelled all by itself. So you can see, you can have a three leads, right? Three leads. The first lead and the second lead will cancel by itself in the equation. So when do the measurement, you won't be able to be affected by the resistance of the wire. But on the bottom side, same thing. So the RT measured won't be. It will be what they call. It will be balanced out, because one pair. You see up there, there's one pair. The bottom one, there is another pair. This is a pair. This is one pair, and then this one. So that will equal out by itself. So in terms of accuracy, of course, this one is better because it won't be, those error won't be coming from the R leads. But very important thing, the R lead should have an equal length in order to, because a little bit of this resistance change will create more errors. That is the whole thing about. So compared to our two wires and three wires, of course, three wires is having a better accuracy. So why then, why this one is already covered, why do we need RTD? When you go to the market and buy RTD, they will ask you, I think our three wires is most common one. Why we need the four wires? Four wires is even more accurate. You know why? Because as far as voltage, when you when you generate voltage to measure something, you tend to have it will be affected by the resistance somehow. Wire resistance, all these things, it will give you this kind of error. But in four wires, what they do is they use a constant current source. Constant current source, V is equal to IR. When the current is constant, only the resistance that give you the value. Everything constant. It won't be affected by. So these four wires, this concept is most accurate way of measuring the RTD sensor, where when there's RT change, it won't be affected by this part. As okay, there are two steps now. One step is still the balance of R lead by itself. Two pair, each pair will cancel by itself, like these three wires. But in this case, it's even the accuracy is even amplified using the constant current source, where only thing change of a resistance, that is the temperature that you're measuring. So voltage won't be affected in this case. So that is the constant current way. So this four wires thing that you can have the best accuracy. Okay, that is and how can you connect? Of course, in this practical here, in this setup here, we also have this module. This is a 3-channel module. That is a 6-channel module. This 6-channel has got this RS485 Modbus RTU output. You can also have this, what they call the Ethernet-based Modbus TCP output that can be fed onto any of the gateway that data are already digitized, and then you want to do this kind of measurement is very simple and it's very, very fast. Yeah. So these are the things, how you can connect 2 wires and 3 wires and 4 wires. Yeah. So of course, there are pro and con, of course. More accurate, more expensive. More accurate, more expensive. Because in terms of module that you want to use also different. Yeah. So that's the whole thing about this 2 wires, 3 wires, and 4 wires. Why I want to show this 2 wires, 3 wires, 4 wires? Because you use one of the example of this RTD to do measurement. In a factory, in a process plant, you bound to have this one. So I hope this kind of information will help you to, when you choose sensors, that will be helpful to you. Okay, so same thing, this one, by using our IoT gateway, you are able to publish things to your cloud. You can make this one share OPC UA, you can do web API, it can be done. So I won't go into detail how you can do all these things, but then that's basically what I want to share today. So that's where I want to share with you today. And then talking about the cloud. Yeah, talking about the cloud side, some of the cloud platform. Yeah, some of these cloud platform looks like that. Is it here? No.
Not this one.
It's not there. Yeah. So just a minute. So we just share it again. This is the cloud, the standard cloud platform that we have. Of course, I won't show how this thing is being published, but maybe just to run through with you some of these things. You can see in our past several sessions, we have shown you how you can plot this chart. In this cloud platform, we are able to give you 3 things. One of them is a visualization of data. You can plot the graph, you can see the meters, you can see the numbering, visualize on the dashboard. You can publish onto a very big screen, if you want. And then the second thing is able to do
get the historical data.
Historical data, like historian, you can build your own historian. That is another one. And then the last one is you can manage all your alert by email, by WhatsApp, by Telegram, or by SMS also. That is come under optional. You can do that. Of course, this cloud platform here, we are able to host another set of data that you can use web API to gather data.
Yeah.
So if you need those things, you can always talk to us about this one. Okay, so that is about the whole thing. Kenan was telling me earlier, he said, today we just have a very short session. Seems like we were talking more than more than usual.
Yeah.
So is there any more thing,
No.
Yeah. So before we go, I think I have one question from the audience that are asking about why when I use the gateway, this is a gateway here. There are more and more people using some of this gateway to do. Why is this your gateway when we link to 232? There's no issue, but when we link to RS485, sometimes the data not very consistent. Not very consistent. So actually the reason for 232 and 485, 232 is quite straightforward. It's based on the peer-to-peer. Peer-to-peer usually, RS232 is a very, very stable system in the world. Maybe I can tell. System, I'm talking about communication. I'm talking about communication, especially for those what I call few devices, 232. Peer-to-peer, there's nothing. But when you come to 485, you are basically talking about, daisy chain, multi-dropping. You have, it's a kind of bus. it's a balanced transmission kind of bus where it will affect by this impedance along the bus on the network bus. That is why some of these things have to be tuned. Sometimes you can see some diagram RS-485 at the end terminator. They need to terminate with one resistor, terminating resistor. That is actually to balance out the impedance along the network. Yeah, so that is very important in order to get it. Actually, this thing also vary when baud rate is changing. Yeah, so that's why this one have to be taken care, especially the programming side. You want to handle RS-485 programming, you need to, the timing is very important. That's why for our gateway, actually it's already built in with this cell tuning. Cell tuning meaning what? Cell tuning meaning RS-485 is like that. On the whole RS-485 network, only one person can talk. Only one person can talk at one time. Just like what? Like walkie-talkie lah. When you press, then only you can talk. But RS-485, when you press, the other people cannot press. When you press, like walkie-talkie, the thing will crash. Nobody can listen to anything. So the timing is very important. So that's why when we want to send data out by using, you're writing a program to send data, you need to open a gate, send, and then you have to close. You cannot open until forever, because the other party, he want to respond to you, he also open up the gate. So to gate opening, the data will crash. Some of them belongs due to some timing and also some tuning, especially on the bus. So that, I hope, if you are listening, you can you get what I'm trying to say. Anyway, thank you for watching this Let's Sembang IIoT session. This is our 21st. Me and 𝐃𝐘𝐘 still sharing thing with you. So I hope you enjoy. And also, I want to end up with this Sembang bukan seberang Sembang. Kami Sembang teknologi, kita Sembang AIoT. So with that, you can see the most important thing is in ExonTech and AIoTMission as a training arm to ExonTech. We always innovate, we apply, and then we share. So I see you again. Thank you very much for watching. Please subscribe to us and like us if you find this relevant to you. Thank you very much. Bye-bye.
Bye-bye.